Hello there. Welcome to the video that explains a little bit more about understanding inquiry-based options. My name is R.Whitehead. I'm an associate professor of architecture and a faculty fellow for high-impact practices at Iowa State University's Center for Excellence in Learning and Teaching. Inquiry-based learning is part of a high-impact educational practice that cultivates higher-order skills as students learn by doing. Inquiries lead to meaningful collaborations and connections across content areas. Learning happens through a process of discovery, creation, and analysis, all within a project context. The project is situated and authentic, and it's driven by a guiding question or questions. Students learn to apply knowledge and skills as they produce proposals and artifacts that are presented and then defended. And as a result, learners show improved engagement, retention, and enthusiasm, and a more in-depth understanding. Our purpose today is to try to sort through different types of classifications for an inquiry-based approach. But in general, an inquiry-based approach is going from a problem, then to some sort of a solution. And this is important as a means of education because we live in a world of interconnected problems. Making sense of them and acting upon them usually happens within the context of a project, particularly when we have to put together, assemble, or create, or somehow formulate and synthesize complex ideas and systems. This is a learned skill. There's a foundation philosophical basis for this based on a constructivist view of education, in which learners are expected to take an active role in the learning process by making sense of ideas and information that they encounter. But not all inquiries have the same effectiveness. Look at the basicness of this. Problem, cloud, solution. So it nurtures the curiosity of learners, but what skills actually take place within the cloud? Within this video, we're going to talk more about how they can be guided, so we can dig into some of the problems and solutions, in other words, how we can better define those. What happens within this cloud of learning that bridges them? Therein lies our ability for more high-impact learning and higher-order thinking. A direct task approach takes a problem such as, how does a toaster work? And it makes it as something that we can answer relatively quickly. It's a direct task. The knowledge is useful, is intended to focus on comprehension and direct application. But to find this requires a basic inquiry. The student work uncovers information that can be relatively easily found, and not many higher order skills are involved in doing so. There's no creation, evaluation, or synthesis of information, and they're really uncovering information that seems to have basically just either a right or wrong answer. What you're looking at here is perhaps a module or an assignment, not a project. It isn't contextualized into a larger project or larger inquiry. So when a curriculum is filled with direct tasks without a framework for exploration, then the learning process has a limited range of effectiveness and engagement. Look what happens when we just change the problem here, instead of something that's a direct task, to something that's seemingly a little bit more open-ended. The complexity and interdisciplinary nature of the problems used in inquiry-based courses requires participants to have an understanding of systems thinking and the various modes for synthesizing this information into a broader process. So systems thinking tries to understand how constituent parts interrelate and influence each other within a whole system. In this case, we're trying to center it around the process of making toast, or more specifically, a process of drawing how to make toast. Why drawing? It allows us to visualize it in a way. It links our hand to our brain. Doing so quickly means we're able to rely on either both intuitive or learned knowledge, and we're able to situate it right away. To talk about the problem, it's inherently open-ended in the way the guiding question is written. It's asking about making the best toast. Not just how toast is made, but because it talks about the best, there's also a particular opinion here about what would make the best toast. So the process that we would normally go through at this point would be a 2-minute process in which everybody draws how do you make the best toast. In this one, you would draw it, pair, and share. Once that process is done, you would want to talk a little bit about what went into this. Immediately, participants draw upon their own experience. If you'd never made toast, you'd have to research it and gather information, etc. before doing this. This is always the first stage of an inquiry process, thus the research and discovery. And then, because you only had 2 minutes, you'd have to determine quickly what to include and how to represent it. Now, this is this critical stage of interpreting and ideating from your research and discovery phase. Finally, you had to present it and discuss it with others. So you had to evaluate what you're going to do, present, and be able to discuss it. As a group then discussing it, you're able to assess and evaluate your answer against other proposals. This is, of course, the final stage of an inquiry process. Answering this question relies on this process. This is what's called a problem-based method. So the definition of a problem-based is its teacher-defined problem. It focuses on the application of knowledge, and there are still many possible solutions. It's important to note that direct tasks within a problem-based method are useful, and in fact, how one makes the best toast may in fact rely on exactly how a toaster can work, or does work, or could be made to work better. So it can in fact link to other direct exercises. Part 2 of this exercise includes more loaded terms in the driving question. How can we improve access to great toast? Again, we can rely on visualizing systems thinking to help reveal the complexity and interdisciplinary nature of this problem. Albeit it's all central to the narrow topic of toast, our inquiry expands past our experience and our ability to Google this answer at all. As you sketch it, see if you can reveal how systems thinking maybe looks for a holistic approach to the research, analysis, and design activities. For example, instead of just thinking about toast, you might think about how air, water, plants, or animals interact within an ecosystem, and that this ecosystem grows wheat for toast or butter. To complete this process, in this case it might take a little bit further because we're zooming out to consider more things. Double the time, say a 4-minute drawing process. Invite the participants to feel free to introduce their own disciplinary bias as well. We're zooming out and we're making connections. Once this is done, look again at the inquiry activities. Compare these to what you found from the problem-based learning. And consider the different types of skills and knowledge that would be needed to adequately address this prompt compared to the previous prompt. The phases are the same, but the depth of inquiry increases. Because it isn't a teacher-given problem, but instead uses a guiding or driving question, more options are available for student voice and choice. So this, what we'd call a project-based learning method. And within this method, learning happens through this inquiry process, a creation process, and an analysis process. It wouldn't just be about drawing how can we improve access to make toast, but creation would be a prompt to actually try to solve that. And analysis would be coming back to this initial problem identified in the guiding question and seeing if that actually works or not. Of course, you may find that you'll need many problem-based learning modules within this. And of course, you might need also direct tasks involved with this as well. For part 3, stay zoomed out and start to identify threats to toast access. Like, let's look at this prompt now. Why isn't access to great toast equitable? These are intentionally very loaded questions. What does access mean? What does great mean? What's equitable mean? And how do we read what that question is really asking us? This is where you'll find the potential focus to a very broad inquiry. Generally, in this phase of drawing or sketching, you can encourage others to find connections between systems that might not be evident, but could be massively important. So what would that mean for you as you re-examine this process again? This is why drawing and redrawing the toast process in different scales and scopes makes so much sense. These are tricky and vexing and even wicked problems, and inquiry-based education is made for this. Drawing is a quick way to help us brainstorm, write, or some other prompt that helps us be able to see that we can try to identify at least where these problems exist. We can find the links and effects and constraints that affect this more complex system. Again, after a 4-minute sort of pair and share process, the connections become even more evident. The importance for research and discovery really is amplified because you realize that you'd want to know more about these potential threats that you found about why access to great toast isn't equitable. You try to interpret what you find from those, and you might try to make some ideations about how to make toast more equitable. Evaluation and presenting is also an important part of that. What you realize is that one project or one problem itself can't be sufficient for the entire class. I'm guessing in the parents share that we had a various number of different results that we found from this. So learners, what we find from this process is that learners need to be part of the process of defining what the inquiry is. The question itself is intentionally open enough that it allows the learners to find a particular way through that, to navigate their way through that. It's seemingly open-ended in the beginning. It's quite aspirational. And there's various types of artifacts and outcomes that may come with this. What you'd find is having the student voice and choice help engage in the research and discovery process allows all the learning to be linked around a great driving, guiding question. This is why critical thinkers and agile problem solvers use this method, both in education and in our most innovative company. It's a practice and it's a skill. So what's right for you? What's right for your class and your students? Think through the level of engagement that you want, the length of exercise, and the overall learning objective. You may find that direct tasks help serve problem-based. You might find that a broader scope of project-based helps, or even a much broader design thinking. They're all, of course, related to the inquiry process, and the inquiry process itself, as we saw, follows all of those stages. Whether those stages are spread out over a long amount of time or condensed into a short amount of time, it is that process of learning how to learn and learn by doing that makes inquiry-based options so effective.